Please subscribe and you can download this code from description below. Multithreading and multiprocessing are essential techniques for improving the performance of your Python applications. While multithreading allows you to run multiple threads within a single process, multiprocessing goes a step further by creating multiple processes. This tutorial focuses on Python3's multiprocessing library and discusses a common issue, memory allocation error. Before diving into multiprocessing, ensure you have Python3.x installed. The multiprocessing library is part of Python's standard library, so there's no need for additional installations. Multiprocessing is a Python module that allows you to create multiple processes, each with its own Python interpreter, memory space, and resources. This parallelization can improve the performance of CPU-bound tasks. Multiprocessing typically involves using the multiprocessing module, which provides classes and functions to create and manage processes. One common issue when working with multiprocessing in Python is running into memory allocation errors, particularly on systems with limited RAM. This error usually manifests as memory error or OS error. Error 12 cannot allocate memory. The primary reason for this error is that each process created by the multiprocessing module has its own memory space. If you create too many processes, you can quickly exhaust the available memory, leading to memory allocation errors. To avoid this, you need to be mindful of the number of processes you create and the amount of memory they consume. Let's illustrate this issue with a simple Python script. In this example, we create 10 processes, each of which allocates 1 MB of memory. Depending on your system's available memory, you might run into a memory error or OS error during the execution of this script. To avoid memory allocation errors when using multiprocessing, consider the following strategies. Limit the number of processes. Don't create more processes than your system can handle. Use the os.cpu_count function to get the number of available CPU cores and adjust your process count accordingly. Reduce memory usage. Optimize the memory usage of each process by sharing data or using shared memory arrays when possible. The multiprocessing module provides mechanisms for sharing data between processes, such as multiprocessing.value and multiprocessing.array. Use a process pool. The multiprocessing.pool class provides a convenient way to manage a pool of worker processes. It automatically manages the number of processes and reuses them, reducing the risk of memory allocation errors. Here's an updated version of the previous example using a process pool.